Saphir is the industry-standard pressure transient analysis software. Although the interface and workflow is simple and clear, ideal for the occasional user, the functionality enables the most advanced user to make the most complex of analyses to the point of even driving the full-field nonlinear numerical model Ruby from the application. The high-frequency, high-resolution pressure response, mainly from shut-ins, can be used to provide wellbore, near wellbore, and in the case of extended buildup or deconvolution analysis, boundary and hence reserves information. The diagnostic plot of choice is the log lot, where the pressure and the Bourdet derivative are matched with the built-in analytical library models and rapid build numerical models. Once data are loaded, quality and synchronization checked, the log lot and semi-log plots are generated from the selected buildup. Multiple selections on different sets of pressure or rate data may be made. The analysis is then based on matching the Bourdet derivative plot with the model. Saphir and Topaz use a progressive workflow from simple diagnostics to analytical and numerical modeling as demanded by the complexity of the case. In this case, a fracture well with constant wellbore storage and dual porosity reservoir model are selected. To match the data, an analytical model is generated based on the results from the analysis tools used in the log lot plot. The Improve option regresses on selected model parameters to improve the match. At each stage of the analysis, the results obtained can be used as a seed for the next stage of interpretation. The numerical model is defined automatically based on the model type and the values obtained from the diagnostic tools or from an existing analytical model. The numerical option allows us to create a model with irregular reservoir boundaries, faults, and additional wells defined interactively or loaded directly from Ruby, the full field module. The Voronoi grid is built automatically with adaptive refinement around the wells and the boundaries. The most complex well trajectories can be defined. The 3D plot containing the reservoir geometry and properties is then generated as the result of the simulation. The 3D plot shows the pressure display with time and cross-sections can be made. Sensitivity of the model response to the model parameters can be run and then displayed on the log lot and history plot. In the case where more than one pressure gauge and/or rate is available for the same period or periods, multiple extractions and simultaneous analyses can be conducted in Saphir. In this case, we show two different pressure gauges, two different periods for the same gauge, and finally, two different rate gauges in the same analysis. Multiple PVTs used for analysis can be defined and the dominant main phase for the analysis chosen. This case shows a comparison of the same data analyzed with oil as the main phase on one hand and then gas as the main phase as a comparison. By selecting two or more buildups separated in time on the same well, deconvolution, with certain caveats, allows us to see far deeper into the reservoir without the requirement for extended and unrealistic shut-ins. In this example, we see creation of the equivalent constant rate drawdown plot and the separate, on-the-fly, deconvolution plot matching pressure and rates simultaneously with the comparison of multiple deconvolutions using multiple buildups. This concludes the introduction to the Saphir Pressure Transit Analysis module. To learn more about this or any of the other KAPPA modules, browse the website for literature, more videos, and example data, or contact support at kappaeng.com or your local KAPPA office.